Okay guys, I got one final video from Montreal I want to release separately, and it's related to the Eon Art electronics. I found them organically just going into the Oracle and Gershman room, which I was going to go into anyway, and I knew nothing about Eon Art a few years ago when I first found them. And then when I started talking to the designer, Stefan, I was like, everything he was talking about was, oh my God, this is so brilliant. This is exactly what I kind of thought would be the evolution of technology being used in amplifier designs, which quite frankly has been kind of stagnant with just the traditional models of A, B, and even some Class D, but it's just same Hypex type modules, and it's not that innovative. And the prototype development phase of just one person developing a prototype. Obviously, I work with a lot of people that have tons of experience, people like Steve McCormick and AGY, where that formula works great because they have so much innate experience. But for most people, they do not have the experience to come up with prototypes like they're doing with Eon Art, using supercomputers and AI to evaluate every single part. And when they do create a prototype, it is going through an immense number of simulations to ensure optimal performance, and how they regulate temperature even in the chassis. Every little thing, connections and distances and parts quality, and how they combine Class A technology with tube amps with Class D for each application in the circuit that makes sense. And then integrated monos has always made sense to me. Preamp and amp synergy is so important. Having a company synergize that for you with supercomputer type simulations to prototype it perfectly. This is true state-of-the-art electronics, and if you have a cost no object budget, this electronics company is probably at the top of my list, if not near the top of my list of any company I would recommend if you have the budget for it. So check out this video where Stefan walks through it, and if you get a chance, watch my other videos as well. It is something special. Enjoy, guys. All right, always one of my favorite rooms because it has three of my favorite brands from Gershman, Eon Art, and Oracle. But yeah, you've got a new release here, is that right?
Yes, hi Jason. Always a pleasure to have you, because you not only you get the technical skill to understand what we do, but you're able to express it clearly, and that's really, really important in the industry.
Oh, thank you.
It's not, we're not doing magic, we're doing science.
Yes.
It looks like magic.
Yeah.
But it
sounds like magic, but yes.
Sounds like magic.
But there is science behind it. That's what I appreciate, yes.
Sure. One of the, we got a new product this year. It's the ultimate amplifier that we do. But in fact, it's from the start of the company. We made that project from the start of the company. So this amplifier is like the newborn, but also the grandfather of all the others, because all the schematic that we use there was already designed long time ago, like in 2005, 2000.
Okay.
And we just take those schematics and simplify them. So we are able to produce the quark, the boson, the other amp that we do.
Okay.
And we wait until now to get the whole products out again. And the products, if you look on the, I can send you a picture, if you look on the web, on the internet, you will see the old products we done the monolith. It's the ancestor of that.
Of what has evolved to this.
Yeah, it's end up there. And there it's a mono amplifier, mono integrated as usual.
Yes,
with
mono
short
integrated.
Connection between the preamp and the amp, a lot of controls. And you get a different way to do it. Like when we designed the boson, the quark, we had to simplify it so people don't end up with three of those, because it's not for every budget. Now what we do is, as it was planned at first, we got filtering. So here on the bottom you got the transformer, but you also have specific filters and specific isolation transformer at back of those for every section of the amplifier. So you will get a filter for every section that will be perfectly sweet to what you need, the maximum filter you can get without sacrificing the sound.
So you put isolation transformers where they're actually needed.
Yes.
That's where you should do isolation instead of isolation everything.
Because of that, this unit, this analyzer is plugged directly on the wall, okay? And if you look, you get 59 Hz, not 60 like it should be in Canada. And if you look there, we already have 3.6% harmonic distortion on the power lines coming from the wall here. Let me tell you, it's about the same thing about everywhere where we go, between now 2 to 5%. And you will get 118 volts or a bit under voltage.
Right.
This unit, this amplifier, is able to correct most of this.
Gotcha.
So the filter is there,
Right.
and from there the computer is there, so it's far away from the music unit by itself. And from there, you have also the converter in DC, because you don't want to move AC between units.
Right.
The AC will make noise that you will get on your.
So it goes
like 80 dB
DC
phonogram.
into there. Okay.
So come in DC here. Here you get the power unit, the reserve, current reserve. It's 750,000 microfarad for 1 channel.
Wow.
And you also have the power supply, the regulation. You have 18 power supply, and those power supply are all with Kelvin regulation, meaning that the unit is there, so far away from the audio system, so the audio circuit, because you don't want to grab any noise coming from there. But you also have, aside of the wires bringing the current, you also have the wires bringing sensors. And you will provide the current depending on what it's really need here, what it's really the consumption is. Now
That's crazy.
Produce that.
Nobody's ever done that, huh?
No. Usually you give the power supply.
Yes,
and you
exactly.
hope that it's enough. But
I know. I've never heard of that before. Okay.
so all those power supply are independent. Go up to here, and on the back to do that you have two 10 wires. It's two 10 wires, military and phenol connectors. Very, very good stuff. And they are locking because you don't want to have any problem with that. Especially with the voltage going there.
Yeah,
and
connections.
the power going
I'm a big fan of better connections, so that's even great to hear. You're thinking of everything, okay?
Yeah, we even think to have a specific holder so people will be able to hold their power cable, because now the power cable seems to grow bigger every year.
Yeah. So you need, yeah.
And we plan that you have an hole with a screw there that we will be able to have a strap and hold it in place.
That's great.
For the real power,
That's
the
needed.
normal power,
That's needed for sure sometimes, yeah.
On the bottom, by the way. So from there, you're going here. And so here, the power is coming, everything is controlled, clean. And here you got the amplification unit.
Right.
You have a tube preamp, tube power supply for the tube preamp. So you will not in phases some harmonic over the other. Problems with tubes, it's in phases harmonic. Problem with transistor, it's in phases harmonic. It's not the same. So it's like putting salt on your meal. Salt is the same thing that I promote since years. You don't want to put the salt on your milk 20 times.
Right.
Because at the end, it tastes only salt.
Right.
So what we do is we try to do not exacerbate those harmonics, because the problem is that not a single component is equal, and those harmonics, they're not the same from tubes to transistors. So we put only tubes, you will get too much of one kind, only transistor too much of the other kind.
Yeah, so you make a recipe, just like cooking a meal, you create a recipe of the right balance, yes.
All our amplifier, and you know that because you already heard those, they are completely neutral, but really neutral. They don't have those kind of Eon Art sound that will be those harmonics
Right.
placing up. No, we don't. We don't have any Eon Art sound. We had
Truly
balance.
neutral, past,
Yeah, and that's what we want, because
pass the signal through.
because we don't want to scrap the job done by the engineer, the sound engineers, and the artists.
Right.
They decide what they want to sound.
Exactly.
Not us.
Yeah, you don't
So-
want to color it, yeah.
Yeah, and from there you get the same pattern that we usually have. So you go to class A input stage, all discrete input stage. But before that, after the tube, you have a class A impedance matching, kind of buffer, and after that we class A, all industry, input stage, and the last stage, it's 2 transistors only in class D.
Okay.
And you got like, that I think is not there anymore, but you got 400 watts in 8 ohm.
Wow.
And
This will drive anything. Yeah.
anything, yeah. And the big important point about those units, you can put as many as you want. So if you have a big loudspeaker that needs to be amped, the amplification on the louds, okay, put 4 of those.
Yeah.
And
Wow.
you link them. So to make those multi-amplification possible, 2 things is needed. You need to be able to control many of those amps from one single point, because you don't want to go on one amp, adjust the volume, go on the other one, or do it with the remote. It's a lot of trouble. So when you touch one, the others will follow, just like we have with the boson since many years.
So we got that.
Sorry. So they want to feed me because they want to
yeah.
fat. That's correct. I want to keep my line.
It's lunchtime, yes.
So the other point is really to split that audio signal with the less losses that you will get. And to do that, we use London transformer, new metal, the top of the line small transformer.
Sure.
Less than 1 dB matching.
Yes.
And what is that gives us is to be able to split the signal without loss.
Right.
And we don't want to make it active because we don't want to exacerbate those harmonics. So, and when you are multi-amplifying, you will pass by that transformer. It will split the signal in 3, so you can go with 3 amplification without signal loss. And when you want to, if you want to go more, you can split it one in another one, and
Okay.
you will get. Well, now you will have a bit more loss, but
nobody does that.
Three of those is 1200 watts. Really old. It's not. We don't do fancy watts. We do real stuff.
Real watts, yes. You even use a supercomputer to help design and prototype. That is very difficult to do if you're just a one-man
but
shop.
we have many big racks, like look like a fridge. A lot of computer.
Yeah, like NASA.
People said you're mining coin. No, we're mining audio.
Yes.
So is that those computers are making simulation.
Yes.
24 hours a day, 30 days a month. And what they do is that they take the 1,000 parts of those and they make all interchange.
Yeah.
It's optimization. In statistics, they call that optimization. It's optimization process where we will check every part, what the value of that part could be, if we reduce that one, if we augment that one,
Yeah.
if we change the line where it passed, because the line of the circuit, even those boards are 8-layer thick.
Right.
And they all double copper, military stuff. And we calculate that because some line need to be a bit longer, a bit shorter, pass there, everything is simulated. That gives you
Yeah.
millions of
It'd be
possibilities.
impossible to build that many units and test by ear. Well, you're using technology the right way to simulate, let AI or supercomputers formulate what the...
In fact, we're using AI too now.
Oh, yeah.
Because that gives you millions of simulations.
Yes.
That take time.
Yeah, without cost.
Tremendous amount of
Yeah,
time.
yeah.
But sometimes you, in that trees of simulation, you find a branch that already give you bad results.
Right, so you
There's
know.
no need to explore the rest.
Right,
Before that, we were doing it by brute force and exploring the rest. Now we had AI processor, specific processor for AI, that are just removing that branch for the pack of simulation. So we gain time. We can simulate even more. Instead of going with 10 variables, we can now simulate 20.
yeah, this is an advantage that a lot of companies in our industry have not gotten to yet, where they're leveraging supercomputers, AI, to do these simulations. They're still doing it the old-fashioned way of having to build a prototype, listen.
Yeah, that's really dangerous. Because I will give you an example. It's like you're a gold digger. And you dig a hole, nothing there. You dig another hole, nothing there. You dig, oh, find something. Oh,
Yeah.
a small bit of gold. That's good. Dig, oh, a bit more. Dig, oh, you found one nugget. God, I found it. but in fact you find nothing. Because if you dig somewhere else, nothing in there, the big one, but you will never know because you never try it.
Right.
We try
everything.
Virtually every possibility, every combination that can exist.
No, and that's where you get optimal results. That's what every industry has found.
When you build a prototype, it's right on spot.
Yeah.
You take all the measurements, because we have a real lab, one of the biggest in North America, and you take all the measurements, put that in the computer, run the simulation again, so improve.
That's amazing. Yeah, this is what stood out to me. I mean, and also, so really for stereo, you need 6 of these, is that right?
No, 6. That's 1 unit.
Yes, that's what I was saying. This is just one channel. People are thinking this is not monoblock amps. This is power supply, filtering,
part of the
and this is integrated per channel.
It's not
integrated
really power
mono
supply like everybody does.
It's more filtering.
It's an amp, but it's split on 3 boxes.
Three boxes for one channel.
For one channel.
Yeah, and then you get another set. But this is what it takes to get true state-of-the-art, optimized by AI and supercomputers for every simulation. What is the price point of these?
Good question.
Probably
260 each.
$260? That's a good price. 260, right?
That's a good price, a deal. And if you sign up today, you get one for free.
Okay, and then if that's Canadian, so US would be $2.
That's right.
For that, we will give you a wonderful prospectus print.
Okay, just a print. Yeah, we'll get a picture of it for $260. But this is amazing.
Double that, you get a picture with the design.
Okay, all right.
Well, okay. No comment.
So,
yes.
One thing important while Zach is here, all our casing, just like it was always done, are made by Oracle.
Yes, he does it, and then nobody does it better than Jacques.
That's Stefan.
Yeah, but it's Oracle.
It's machine. It's family work. Teamwork.
The king of timeless design. Everything he makes lasts forever.
We design the box. They enhance the design. And they produce that wonderful thing.
Yes, it's beautiful.
And
inside and out. That's the key.
You have a lot of things
it's nicer inside because there's not. I'm sorry, it's nicer out because there's nothing inside at this time. At this point.
Okay. Yes.
It's just a mock-up.
Okay, the mock-up right now. Okay.
Eventually, there'll be something in it.
All right, so next show I'll see that.
Yeah, that's right.
Oh yeah, because it's already sold.
Okay, maybe one day I'll have it in my home too. That's awesome.
And the other things that is those casing, they are everything is open, will open.
Right, like
those ones.
like this one over
German
here.
Mechanics.
Yeah, we'll show. This is how it's easy to access. Yeah.
Oh yeah, it's on German mechanics.
So even No, you don't have to, and it's beautiful.
Now that's became the small model.
Yeah, this is the small model now.
But
yeah.
One other things that I want to show you there is the furniture stand. That's a very special stand. Some people don't want it, but
really?
It's a special stand that's made for those bosons. But that's the prototype of it. So we asked to have it longer so we can play with the cables and make tests on it. But it will be shorter. But just the length should be.
Yeah, you need a stand for this for sure. You got 3 pieces.
Yeah.
6 pieces total.
This stand is made by a partner, Saline Meuble, here now. But he's also the one who makes all the furniture in the room.
Okay, cool.
So we want to always try to push collaboration between companies.
Yes. And yeah, you got a great collaboration here.
It's wonderful. It's all wonderful. With Oracle, turntable, the source. We do a DAC too. Now it's turntable string, but our DAC is good too. And so that's what we have new here. But you also have one new there that you didn't sell.
Okay, let's go take a look at. Oh, let's go take a look at that.
Yeah. So I will just make that. You get the biggest one there. The second biggest is.
We covered this one at the last. Yeah, we covered this one last year. Let's go take a look at the. And what are we starting at price-wise here?
This one, $35,000.
Okay. And so it's a stereo amp, right?
Yeah, it's a stereo amp. You got a lot of old technologies in it.
Okay.
Don't go as far as the other one, but you have a lot of old technology. Like, still the same architecture, tube power supply, tube preamp. We have all the capacitors on board or on socket, meaning that those amps will stand for a lifetime. You just replace the board and you're good again.
Okay.
So
How much power does this one have?
208,
Oh, yeah, plenty.
a lot of power,
Yeah.
and they're at 8 ohms.
It's a part. You have one for the preamp stage and a transformer for the amp.
No,
Is that different?
that's what it looks, but
Yes.
we have one for the controlling system because you got 3 computers in those.
Oh, okay.
And we use a lot of technology inside. You have tubes, but you have modern tube system with microprocessors to control
Okay.
them, So that's control system, and the amplifier, the integrated amplifier, so all
Okay.
from that power supply.
Interesting. Okay.
Since we are having Class D output stage and Class A are for the best, we have a very high ratio for conversion, meaning that for us, 1,000 watt, for that amp of that will give you like 700 watts, you get a power supply of 900 watts, and 900 watts with a 94% ratio, it's largely over what you need.
Yeah. Well, it's
So
probably as much as you
that's
could
why
take
it
from the
doesn't look
wall.
Big, but it is.
Is this a 20 amp cord?
15 amps.
15 amp, yeah.
Even those big ones are designed to be able to use on 15
20.
amp.
Oh, 15 amp, really?
Yeah. The boson, you can use those on 15 amp, one line. But the big one, you need one
You need it.
independent. 15
Gotcha.
amp. And dedicated will be better. So the other thing is that those capacitors from German Mondorf,
Mondos,
they're
yeah.
22,000. So they don't look big, but they have a really, really good capacitance. 22,000 microfarads.
Microfarads, okay.
Enormous. For a 200 watt, you got 66 steps.
Wow.
And you also have other on us.
Yes. So you're combining basically solid state tubes and Class D.
Yeah, that's what we do. But we use Class D for what it is. It's
Yeah.
a good way to give power.
Power, yeah.
It's the best way to give
Right.
power. So meaning that our 2 last transistors are in Class D. And the fact that we like Class D is because you don't need to have so many transistors to do the thing.
Right.
For example, compare that to a Class A, and they get 24
Yeah,
transistors.
you'll
on
see
each
like
side.
a big row of them.
Yeah.
Yeah, like the old Krells
What's
and all
happening is
that.
that the signature of one is added to the other one,
Right.
and to the other one at the end. It doesn't sound clean.
Yeah, it looks impressive to see all those transitions, and people like look under the hood. Oh, that's cool, but it's actually
Always the same example.
it's not
Take
really
the
good
salt,
sounding. Yeah.
Put some salt on your meal.
Right.
It will be wonderful. Put it 24 times. I'm not sure you will like it.
Right. Right.
Or if you like it, it's because you're so much used to salt
Yeah.
that you're not able. Your taste is disturbed. You're not able to see the difference.
Yeah, no, I totally agree because, yeah, sometimes high-powered amps in those traditional designs don't sound that good because
Yeah.
it looks impressive and people think they're getting a lot
But
for their
it's
money, but it's worse to design it that way.
Sure.
So you're actually taking the best of all the technologies, simulating it, making sure the prototype passes all the muster of supercomputing and AI, and then you build a prototype, you listen, and yeah, this is taking the best of all the technologies, which people on their own find Class D fine. Some people find tubes great. Now you're taking the best of all the quality.
Yeah, and we're able to match it because it's not easy to match it. You don't
That's right.
just simply place a tube preamp,
Right.
with a solid state, or
Or just throw a tube buffer. Yeah, like
like
that's how people have done it in the past. They'll put a tube buffer and they'll get tubes, but then they'll use a solid state
And you
amp.
have to be really precise on operation point.
Right.
That's why those filters there, they're encapsulated. The copper unit is used as a shield.
Okay.
But aside of the shield, they are heated. They have a resistor to heat inside. Aside of the filter, they have temperature sensors, and we keep them at the same frequency, by the way, because the components change value with temperature. 1 degree make a big difference.
Yeah.
So we make sure that they never change value. We are right on the spot for everything. It's like filament on tubes. They should be 6.3. Not 6, not 6.6, because the tubes will not stand. It will wear faster. They need to be really precise.
Right.
So that's
And
what-
you even regulate the temperature in your chassis too, because temperature makes a big difference.
Yeah, but in this model, we can't do that. There's not enough space.
Right.
So what we do is that what is really important to be sure that it do not move in temp we make it in encapsulated box, another box on the back.
Okay.
So, and we regulate this zone inside, like
Okay.
an oven, micro oven, just like they do with DAC. They have crystal, the clock
Yeah.
in micro oven. We do the same here for them. And also the idea that we have here is that the system need to be able to be the same plus as possible. But I will finish on the. I want to explain about that, but I will finish on the heating. Those big units, all those big units, they are temperature controlled. In fact, we had to add more temperatures inside because they cool so well by convection because you have chimney systems.
The convection, yep.
Yeah, touch them when you go in front, touch them, they are really cold.
That's amazing.
If we took the time, but they are cold. And in fact, we produce temperatures and we have a lot of temp sensors. Here we have one or two, but on the other one, it's full of temp sensors and each part of the board is regulated to the best temperature for the best operating point of that part. So, and what is now that I wanted to talk is about that, the volume cards. We don't do volume as other. We have relay there, but it is not for the volume by itself, just for communication in the system. But the volume controller is made by transistors and resistors, just transistors and a resistor.
Okay.
So you will not pass in a load of parts. That will change the signal.
So it's not like a resistor ladder or anything?
No, no. What we want is to keep the signal path the simplest possible. So you have a transistor, you have a resistor, transistor will change its value. You have many of those, not because you use them all, it's because that resistor and transistor have a certain range that they can go, and after over that range, you go on the other range.
Okay.
So that's why it's made like this. And since of that, we're not able to make good, but it's not an advantage to make like 256 ladder, or not a ladder, but transistors and resistors to have much more point.
Right.
But it's useless anyway, because what we done is that people choose those boards depending on the efficiency of the loudspeaker.
Right.
So we had a board for 90 dBs and lower, one from 90 dBs to 100 dBs and one over 100 dBs.
To try to match the right gain for the speaker. Yeah.
Exactly.
That's brilliant, yeah.
Exactly. That's what we do. And because we do that, we're able to be sure that the signal that the amplifier receives, aside of the level of the signal, it's always the same. Meaning that you can optimize even better.
Right.
And because you don't have to take in consideration that range. You take in consideration the range that you...
Because so many preamps won't work with certain amps, and then certain amps don't work with certain speakers with the gain combination.
People say, yeah, but when you change the loudspeaker, well, yeah, but you change the board.
You just change the board, okay. That's amazing.
It's just a slot, you know.
No, that's thinking of everything like you always do, and this is what stood out to me. I don't think anybody in this space, no matter how much you spend, is doing the level of attention to detail you guys are doing. And so that's why I like to feature you guys, and hopefully you can make it to America, one of the shows down there one day.
That's the plan. You will have to tell us where to start.
Okay.
What's the best show to go?
It's too late for Expona probably, but there's a great show in November in Washington, D.C., not too far, so maybe you can do that one.
DC. Maybe I will go there.
Okay. Well, great talking to you. Awesome product. And go to eonart.com, right?
Yeah.
Okay. Awesome.
Anyway, if you look for Eon Art amplifier on Google, you will find us.
Yes. And also check out my other videos from the past. All right. Thank you much.